Hello everyone, welcome to IAE. In this video, we will solve a numerical on power electronics, which states that a half-controlled single-phase converter, which is this one, is shown in figure with the control angle alpha equal to 30 degree. So the firing angle is given to us 30 degree, alpha equal to 30 degree. The output DC voltage wave shape will be, there are four options are given. The one option is this one, another is this, another is this, and another is this one. We have to find out which one is correct at this output voltage. By looking at the circuit diagram as it is given in the problem, what we can understand that IDC is the output current and it is shown as a current source. What does it mean? It means there is a large inductance connected, right? And that makes the output current to be a continuous current source IDC. Okay, fine. So to find out which option is correct, we have to draw the output voltage waveform. Okay, so let us draw the output voltage waveform. Just by drawing the input voltage, from there we will draw the output voltage. This is our omega t axis and this is the input voltage Vi. Here we will draw the output voltage Vo, as well as we will draw the current waveform IO. Okay, this is our IO, which is nothing but IDC. Okay, so the firing angle is given as 30 degrees. So what we can say, T1 is triggered at 30 degree and T2 is triggered at pi plus 30 degree. So let us say this is our 30 degree point alpha, and here T1 is triggered and T2 will be triggered at pi plus 30 degrees. So here it will be T2, right? So let us mark the zero crossing points first. This is a zero crossing point, this is 2 pi point, and this is our 3 pi point. Okay, so at this point when T1 is triggered, we say T1 and D1 is in forward bias state, and T1 and D1 will conduct from alpha, which is 30 degree, to pi. So let us mark these points also. So from this point to this pi point, T1, D1 will conduct, right? And if T1, D1 conducts, the output voltage will be same as the input voltage. This input polarity, positive and negative, they will appear at the load. So the output voltage will be same as the input voltage. Now what is the current waveform? They have given us IDC. So it is constant, we will assume. So this is a constant current is flowing. And here, who is in responsibility for the conduction? T1 and D1. So let us give a name to it, T1 and D1 in this segment alpha to pi, right? Now from this point to this point, what will happen? From pi to pi plus alpha. See here, as because the current is continuous, so we must say T1 is not in off state, because the current through the thyristor, when it is 0 or below the holding current, then we only know that the thyristor will be off. And as we see here, the current is not 0, which is a continuous current is flowing, right? Ripple free continuous current is flowing. So T1 is not off. And this is the negative half cycle is starting here. And as we know, in the negative half cycle, D2 will be forward biased, because this polarity will alter to be negative and positive. Now we see T1 still in conduction and D2 is coming to the picture. Then what will happen? You know, this current now will pass through this, meaning the output current will free wheel through T1 and D2. The current will not go back to the source, it will free wheel through T1 and D2. And when they are in forward biased and they are in conduction, the output voltage will be 0 because they are short circuit. And the current will be this one and the output voltage will be 0, right? And here the conduction will be through T1 and D2. So let us write T1 and D2. Now what will happen from pi plus alpha to 2 pi? We see T2 comes to be the forward biased from the pi point, but we have not triggered yet, right? Because it will be triggered at pi plus alpha only. So when we trigger T2, suddenly T1 will off, because the reverse voltage will appear at the T1 and T1 will come to the conduction, and this positive voltage will appear here, and through D2 the negative voltage will appear here. That means though the input polarity is altering, but the output voltage will be this one, right? And here the conduction will go to T2 and D2. Okay. Now in this cycle also the same thing will happen. This is same like the positive half cycle. So you can say that, or you can draw the voltages also, but that much is not required for answering the question, because they are asking what will be the output voltage, right? So we see there is no negative swing, obviously, because this is a half controlled rectifier. Two thyristors are there, two diodes are there will not be any negative swing. So obviously this can't be the answer, right? And also this is a controlled rectifier, firing angle is there alpha, so this can't also be the answer. Also this is a full wave rectifier, full wave, full control, this can't be the answer, and this will be the answer. So without this, drawing this diagram, if you know what type of circuit it is, and if you know the concept that in a half controlled rectifier there won't be any negative swing, you can directly answer this will be the right answer, right? Hopefully you have enjoyed the video. Thank you for watching the video.